Good morning all. Today I want to introduce my latest purchase. Yes, I bought it on eBay. It's this 180 watt electronic DC load constant current. This is an extreme example of putting really tiny components and really massive components on the same PCB. There are some 0201 resistors here. So tiny you can barely see them at this distance. And then there's this thumping great heatsink with these two massive fans. And the heatsink with its heat pipes pushing down on this aluminium heatsink, it pushes down on this semiconductor, and that's indicated there. It's almost certainly a MOSFET, but it's sandwiched between the board and that heatsink. And it's pushing against that, but at the same time pulling on these four posts here and here. So the back of this board is kind of almost spherical. It's bulging out, it's domed at this point, and you can see this sort of not straight line of the printed circuit board. It's all under a lot of stress. So let's go around this thing and see what we've got. Well, a lot of sockets. USB type A input, and it is an input because it says USB in there, but it's also a quick charge trigger port, which is quite interesting. We'll come back to that later. There's a two-way terminal block here for the main power input that you're measuring and applying a load to. This can apply a load of up to 20 amps or a maximum voltage of 200 volts. Now, I'm never going to put 200 volts through this thing because that's quite scary. There's a DC barrel jack here, which is just paralleled with this. There are lots of USBs, a mini, a micro B, and a type C there. Round this side, there's a JST 2-pin here, which I believe is connected across the buzzer so that you can use the buzzer enable signal to trigger something else. There's a DC barrel jack, which is an output because it says it's an output here, out. And then on the back, there's another DC barrel jack and a USB micro type B for the power supply. Power, and it says on the back here, power, 6 to 12 volts, 6 to 12 volts, 6 to 12 volts. So there's no ambiguity as to the range of the power supply voltage. There are two potentiometers here with knobs on them. One is coarse, one is fine. They both essentially do the same thing. They vary the current, the constant DC current that is applied to the power supply coming in. And there's a single button here because the display and the whole measuring interface has a one button interface, and it's quite good actually. So let's power this thing up. Now it's supplied with this rather naff looking 9 volt 1 amp switch mode power supply, which plugs into the barrel jack on the back, and of course 9 volts is right between the 6 volt to 12 volt power supply range. So let's get it switched on. Okay, plug it in and then I'll work out whether or not the camera is getting a good, it is getting quite a good image of the display there. So let's see what's on this display. What was that sound? I heard a pop, and although this still works, it smells bad and it's all warm on the top. I'm not convinced that this is a very good power supply. I didn't like the look of this thing since I first set eyes on it, so let's give it a bit of examination. Oh yeah, that's squeezing nicely. That's gonna pop. Well, this ain't good. There's some liquidy stuff inside the lid, and I think you can probably see that the main 400 volt capacitor is all bulging. Let's take a closer look. Yes, that pop I heard was this 400 volt capacitor rupturing at the bottom there, and all its electrolyte has come out. So that's not particularly good. It's 4.7 microfarads, 400 volts if this thing would focus. Well, I wasn't expecting this so early in the video, but yeah, what a piece of nasty. So let's shove the lid back on and be done with it. I shan't be using that power supply no more. And so that brings me neatly on to how to power this. And one option is the old, and I mean old because long since not been able to get this, the old QD184 SX T's power bank, which is a brilliant power bank. So I'm just going to set this up for 9 volts. Oh, it's on 11. What does that do? 11.5. Press and hold down potential, and I'll put this to 9 volts, and then I'll put 9 volts straight into the back of this unit. Now the other thing I've got to do is to make sure this doesn't come on auto off. So I want to set it to not. That's the one. Right, let's plug the plug into the back of the unit. On it comes, and that's interesting because this is switched off. Now this old power bank has a boost converter, but when it's not running, it still puts the 3.7 volts from the lithium cells onto the output. So this is running on 3.7 volts. It works at 3.7 volts, but it says on the back it has to be a minimum of 6 volts. So let's switch this on. Watch that blue LED. Does it brighten up when this goes to 9 volts? No, not noticeably. So let's have a look at the display and the one button interface. So you can see we've got volts, that's the incoming supply voltage. Current, and that will increase when you turn these pots, but of course it won't if you haven't got a supply voltage. We've got watts derived from these two presumably, and then the time derived components of amp hours for total charge, watt hours for total energy, a timer. This is a temperature measurement thing, and I think it means the temperature of the semiconductor under the heatsink. That's what I believe. And this is an effective ohms of the load, I presume, which is just simply a calculation based on V and I. V equals IR. So here's the one button interface in action. Double click and it resets amp hours. Treble click and it will reset watt hours. There it goes. Quadruple click and it'll reset the timer. There it goes. Now if this interface looks familiar, well it is, because it's very, very similar to the one I've got in the shed. This one, in fact, and this is the one I'm using to measure what's coming in from my big solar panel, 35.3 volts. No current going out and therefore no watts. But if you watch the button, double click resets amp hours, treble click resets watt hours, quadruple click resets the timer. It's 5 degrees in the shed, it's a bit chilly. Now there is one difference between this one and the display on the electronic load, and that is that this is powered by the input voltage. On the electronic DC load it's not. You have to have the separate power supply. And so hence the separate 9 volt power supply connection on the back, so that presumably it doesn't interfere too much with the incoming voltage current measurement that's on this display. So just a quick cycle around the display pages. It's very similar to the one in the shed. Backlight is on. You can change that through the one button interface, and it's quite intuitive. I can't remember how to do it now, but let's go around all the displays. You've got the Chinese one at the beginning, then you've got this one with all the numbers, but not terribly pretty. Then you've got the ones with the big volts and amps, laid out in a slightly different sequence. Backlight on. 300 volts is the upper voltage limit. It just beeps the beeper if you go to that voltage. Less than 0 volts, you can set that so that it will beep if the incoming voltage goes below a certain amount. And on the display in the shed, I never really understood what that was for. But of course here, it's if you're doing a battery test, you can tell this thing to start beeping when your battery reaches a voltage you don't want it to go below. That's what that's for. Over 100 amps, you can get the buzzer to beep if more than 100 amps comes in. This thing's only rated for 20, so that's not quite set right. And over 185 watts. And this was the limit I was hitting when I was measuring the current coming out of the cigar lighter accessory socket on the power bank, and then back to the Chinese screen. Although I seem to have had contact bounce there. So let's just go back to that manually. There's the Chinese screen. So I just thought I'd bring you to the eBay listing. This is the one I bought, £40.62. Although he had make offer, so I offered £36. He came back with a counter offer of £40. I saved 62 pence. I bought it from GFEC SS793, and it turned up pretty quickly because I bought it from a UK seller in Leicestershire, because the Chinese advantage is kind of gone now, isn't it? You know, cheap stuff from China with no postage and no VAT. Not anymore. eBay collects the VAT. eBay have become the VAT man. So yeah, you get the crappy power supply, which just went pop and blew up. You also get these USB to crocodile clip wires. This doesn't look quite right to me. A huge lithium power bank going straight into that USB socket. But let's take a look at some of the stuff that they write about this thing. Again, 200 volts, 20 amps. But there's something here. Yes, here we are, look. 4 to 30 volts DC. Voltage provides electricity for testing system. Now, I assume they mean there that's the range of input voltage. But on the unit itself, it very strictly says 6 to 12 volts. And I have noticed when I put 5 volts into it, it's slightly inaccurate. So maybe they changed it in order to work within a range which gives you more accurate results. But that does look to me like that was the original spec for the power supply on those sockets on the back of the unit. Well, masses of stuff here on what you can do and what you can't do. A lot of it's gibberish. There's the one button interface, which I quite like. Quickly button twice, capacity reset. Quickly button 3, power reset, etc. Press and hold the button instantly and you reset all of the time-based parameters, milliamp hours, watt hours, and indeed hours, minutes and seconds. So now that we've got power applied to this thing, let's actually put something on the input. So I'm going to use this. This is coming from the lead acid batteries outside. Let's plug it in. Make sure these two are turned down because this is very analog. If these are up, then it will apply the load immediately. And if this one's up, it can apply lots of amps to it. So let's plug that into the barrel jack. I'm going to put it on one of the screens where you can see what's going on a little bit better. This one I think is my favorite. So the incoming voltage is 12.7 volts. This pot is actually quite good if you're testing USB inputs, because this one has a 2 amp sweep. So even if I turn that full up, oh yes, and that's when the green lights and the fans come on, which is quite fun. You can see that it's only applying a couple of amps. So this is described as the 0 to 2 amps pot, and also the plus or minus 2 amps. Actually, it'd be plus or minus 1 amp, I guess, on top of whatever the coarse pot is applying. So let's turn that down and turn the coarse pot on. And that, I think, goes up quite quickly. And I'm not sure how many amps this supply will sustain. Probably not that many. So let's use the fine pot. And it's only when I think you get to about, I can't remember. I thought it was 1 amp. Maybe it's a certain number of watts. The fans are turned on, and of course these fans have these silly green lights in them, and so the lights also come on as well as the fans. But if you're taking less than a certain amount of power from the input, then the lights and the fans don't come on. So let's be a bit more scientific. I'm going to apply a constant current of 1 amp, and at 12 volts, if it sustains 12 volts, I hope it does. Of course, we're pulling 12 watts. Now this is where things get interesting, because there's a barrel jack on the side here, and I thought I'm going to plug this lamp into it to provide an additional load. And certainly the lamp lights up, and okay, there is additional load. Well, something's changed on the input, but it's still saying that it's drawing 1 amp. So the constant current appears to be constant despite putting an additional load on this output connector. However, since there is now some current going into this lamp, the current going through the big MOSFET under the heatsink here must have fallen a bit. So you can offset the amount of current going into the MOSFET under here by putting an additional load on the outside. Oh yes, I think when it fell to 11.9, that's just the batteries outside discharging. So 11.7 now, plug this in, and you shouldn't see any difference here. But like I say, there will be less power being consumed in this heatsink assembly. Now that's interesting, because it means that by plugging an additional load into the output socket, you can actually extend the power capability of this from 180 watts up to something a fair bit higher. And let's go and look at another eBay listing. So this one, it's the same unit, but they've got this thing here up in the main image. In fact, let me click on it. No, that was a bad thing to do. Oh, it's all gone totally pear-shaped now. Right, so we've got 200 volts. Oh, let's keep my pointer up here. 200 volts, 20 amps, 180 watts. But here it says can DIY 300 watts. And I'm assuming that the way you do this is by adding an additional load to that output socket. Now, if you're bringing 180 watts up to 300 watts, that's an additional 120 watts. In order to keep the current down to a realistic, I don't know, 5 amps through those barrel jacks, that's 25 volts. Is it 25 volts? 5 times 25, no, 24 volts, yeah. So at 24 volts, you could apply 5 amps into, I don't know, a 24 volt light bulb or something on that output jack and get your DIY 300 watt maximum load onto your input supply. So without turning on these pots at all, if I just plug in my bulbs, of course I'm immediately drawing 8 watts. These are 5 watt car bulbs, and of course they're 5 watts at something like 14 volts with the engine running, so they're a bit less at 12 volts. But that's enough to make the operating system think, oh, I need to turn the fans on. Fair enough, even though of course there's no current going through the semiconductor sitting underneath the heatsink, but never mind. So I think that's the way to extend the functionality of this. Now that would require that we go to the 185 watts maximum and we change it. And I think you press and hold. Yes, that counts down. Then double click, I think counts up, and then press and hold, continues. Double click. Oh no, single click. Oh, that's confusing. Let's go around to that again. I love this one button interface. 187 watts now. Press and hold, was it? Yes, and that's increment. Double click, press and hold, still increment. Click. No, that gets out of the display. I haven't fathomed this out yet. Okay, I've got it. To change direction, you treble click. That goes, oh no, treble click to go down, press and hold to run it continuously. Double click to go up, press and hold to increment continuously. So we could, so I'll do treble click to go down. Oh, I pressed that, I did a single click. Single click takes you out. That's so annoying. I wanted to set this to 220, so what is it? Press and hold, I think will increment. No, that's decrementing. Oh, well, that's it. I've done it. That's fine. So bring it round to my main display. And there we are. Now this won't start beeping. And I think it shuts down as well. I think the beeper signal is routed round to the constant current load. So if you go over that load. In fact, I could set that really low, couldn't I, and test that. I'll do that now. So I'm setting this to 30 watts. Double click, treble click, treble click, 30 watts. So I should, if I go back to the main measurement screen, be able to now trigger that 30 watts by increasing the current of the load based on the semiconductor under the heatsink. Can I get to 30 watts? Not without a little help from this pot here. And there's the beeping. Now, does it turn off the load? It's hard to tell from here. I think the only way I'm going to be able to tell is by not having my additional light bulb there. So let's trigger the 30 watt trigger. That's 12 watts, 20. There's the 30 watts. Yes, you can see that the fans have stopped running. So my guess is that when you hit your watt upper limit, it turns off the load, and turning these back down doesn't do anything. You have to press the button to reset it. Now, just in here, it's hard to see very well, but there's a chip there, MC34063A, and an inductor. Now that's a buck regulator. Oh, it's a boost or buck or inverting regulator, but my guess is that the power supply comes into that, and that's what's supplying the system. Now that's rated 3 to 40 volts. So is that where they got the 4 to 30 volts power supply range in the eBay listing, even though on here it's been reduced 6 to 12 volts, because they discovered that if you go outside that range, this thing tends to become a little inaccurate. Let me see if I can show you what I mean. Okay, 11.8 volts, around about 1 amp. Now I'm going to turn off that power bank so that it drops to 3.7 volts. I have to press and hold and wait for the word off to appear. And it's gone off. And now you can see that this has gone wildly inaccurate. It's saying 14.4 volts, 1.46 amps. The green lights have gone dim, the fans have slowed down. But you can see that with a 3.7 volts on the input, it's just gone mad. I'll switch the power bank back on. That takes a few seconds to actually kick in. There it is. And immediately the numbers have gone back to what are normal. Now I did notice that if I put 5 volts into the back of this thing, instead of the 6 to 12 volts, nominal 9 volts, there was also some slight inaccuracy. So I think that's why they've updated the advice on the power supply so that it's within the range 6 to 12 volts. Now it has to be said that this thing is constant current only. You set these pots and you set a constant current. There are other electronic DC loads on eBay which have the full color display, TFT display I think it is, and they can be set to constant voltage, constant current, constant power, I think, possibly even constant resistance, I don't know. But they're much more sophisticated than this. This is just a very simple set your current with these analog pots and you get constant current, only constant current. Now there's a whole nother chapter on this really relating to USB, because there's quite a few things when you're measuring USB that aren't quite the same as when you're measuring DC through these two connectors, which I believe are directly in parallel with each other. But I'm not going to cover that in this video because it's getting very long, so we'll come back to that in another video. But for the moment, that's the 180 watt DIY up to 300 watt constant current electronic DC load, which costs about £40. That's it for now. Cheerio.